In this video, we are finding the sum of a telescoping series using the method of the differences. It consists on separating the expression for the general term of our series into two fractions and hoping that one of them has a negative sign in front of it. This will be the key for our method to work. We are going to split our fraction into a over r plus 1 plus b over r plus 2. For that, we need to figure out the values of a and b that make that equation true. How? Well, we expand a times r plus 2 plus b times r plus 1, and we collect like terms. The terms with r, ar plus br, can be collected as a plus br. The terms without r can be collected as 2a plus b. For our numerator to be equal 1, we need a plus b to be 0 and 2a plus b to be 1. This leads to a pair of simultaneous equations. To solve it, we could subtract the second equation from the first one. This leaves us with 1a plus 0b equals 1. So a equals 1. Since a plus b is 0, b must be negative 1. Now that we have separated the fraction into the difference of two partial fractions, 1 over r plus 1 minus 1 over r plus 2, we find the sum of the n elements of our series. We substitute r equals 1, r equals 2, etc., r equals n minus 1, and r equals n. It is now that we can start noticing patterns. The second fraction of the first term cancels the first fraction of the second term. The second fraction of the second term will cancel the first fraction of the third term. This is typical of telescoping series. In our case, it means that all the fractions will cancel each other out except for the first fraction of the first term, a half, as it doesn't have previous terms to cancel with, and the second fraction of the last term, as it doesn't have any terms after it to cancel with. The result is a half minus 1 over n plus 2. Now that we found an expression, we can use it to evaluate the sum of the first, for example, 8 terms. By replacing n with 8, a half minus 1/10 equals 0.4.